All right, guys, this is going to be the first time we're trying to do this as far as pre-recorded videos for class. This is for week 3, first day, so week 3, lesson 1. So this lesson is for Tuesday, March 24th. Currently, this is for any of the HVR155 classes. So that's who this is for. We're going to be going over pilots and ignition systems today. There will be a number of questions I ask during this, but I will go through the slides and I will go ahead and start getting everything going from here. So, pilots, all right? Pilots are going to be a main source of ignition that you've got for older styled systems. They're going to be one of those commonly used ones, especially for older equipment. It just was what made sense. If you've ever had an old gas furnace or water heater or an oven, you may have had a pilot light that would go out on occasion and you have to relight it. So you may have experience with that. Or honestly, one of the more common ones nowadays is propane gas fireplaces. They're very common in a lot of homes, and they have a pilot system very similar to our gas furnaces. So they're still used pretty regularly throughout the industry. It just depends on the age of the equipment, what the application is for it, whether or not it's going to need that pilot system. So for tonight's questions, the first question that you must answer for your attendance: when is a standing pilot active? First question again is, when is a standing pilot active? All right. So pilots, again, they've got 2 different styles that you're going to learn about tonight. We'll talk about intermittent pilots and we'll talk about standing pilots. Now, standing pilots are the original one. This is when we first were having automated gas controls become a regular thing in our modern mechanical equipment and heating and air conditioning and all sorts of engineering. You were getting to be, it's automated controls. So the standing pilot was the first one. And how it works is it has a flame that burns continuously. It doesn't matter if you don't have the heat on. Doesn't matter if you don't have the oven going. Doesn't matter if you don't have the water heater on or the gas fireplace ready. A standing pilot will continuously burn fuel in order to keep a flame present in the system. So why would we need a flame in the system at all times if we're not heating, if we're not doing anything with it? Why do I need to have even a small flame? And the reason for it is what the pilot works to do is its job is to ignite the rest of the gas. So modern systems, we use weird, crazy silicon carbide, new space age technology materials kind of thing. They're very much synthesized stuff. Now, back in the day, they didn't have, that readily available. It was very, very expensive to get anything like that. So you had a limited number of options. And a pilot was the easiest one because we learned about it the other day. Natural gas and propane, for ignition to take place, they've got to be at about 1,200 degrees Fahrenheit. All right, that is a huge amount of heat for anything. We've all been there. We've had a 90-degree day, and we know that's a hot day. But 1,200 degrees, it's really, really hot. It's basically what you're going to see inside of the center of a flame on, let's say, a propane torch or on some high-end lighters. I know butane's not as stable, but you can get that really, really high temperature with that. So that was, it's tough to get that temperature, with limited technology and all that kind of stuff. But if you have it where it's just, hey, why not use a fire to light the fire? It just makes a lot of sense. So you have it where a pilot system is going to basically allow for you to ignite the rest of your gas, but it's got to do it safely. We can't have a flame just burning with no one watching over it, no one taking care of it, no one noticing. So there are a number of safety devices that we're going to see. So number 2 for your question for tonight, what is the purpose of a pilot light? What is the purpose of a pilot light? That is your second question for the evening. We've got it where pilot lights are going to be used in a number of different places, but we'll see and we'll talk about more and more stuff as far as pilots are concerned as we go through this. So, all right, we've got third question. Here we go. Third question for tonight for attendance. What are 3 types of safety devices used on gas furnaces? All right. So gas furnaces, we've got where there are 3 different safety devices that are going to be used, and they each have advantages and disadvantages, and they were both, they're used at different locations, but also depending on the time the machinery was built and created, at the time that something was designed and engineered, that's going to change the value there, or not so much the value, but what material or what safety device is going to be used. So the first one it has listed there, basically a safety device, the whole idea behind it is what I just said. We have a pilot, all right? It's a flame burning, and we can't have a flame burning unless it's being watched, all right? And we can't hire a guy to watch a flame in our house all day, so we use a flame sensing device. Now, there are 3 that you're going to see most commonly in pretty much every situation. I've run into all 3 of these in various different situations. I'll tell you what's most common when we get to it. But I would say number 1, thermocouples, thermopiles. Those thermocouples and thermopiles, those 2 are related. We'll talk about them more as we go through the slides. You guys are going to get more information on them. Bimetallic safety device, you guys can probably already guess how that's going to work. You've all learned how bimetal operates and works at this point. You've been through that section of controls, and you understand the importance that bimetal plays as a mechanical control and as a safety. And then number 3, our liquid-filled remote bulb. This is the most confusing one probably out of the systems because it's the most mechanical. And it's not that it's so impossible to understand that it's crazy, weird, out there concepts or anything like that. It's just the fact that it's not used on modern systems as much. It's going to be used on your much older system. Same with the thermopile. It's going to be, again, another older system thing you're going to run into. We've just developed different ways to detect a flame that require components to have less maintenance. They require less repairs, less part replacement, and they make it where, because of that, we're not going out there all the time, and it makes it so we have more time to go do other jobs, more major, repairs and stuff like that. You're going to hear about it, and you hear about it now already, and you hear about it in your other classes, how things are being automated, things are being updated, and we're having it where there's less and less parts to troubleshoot on an HVAC system. And that comes as a good thing and a bad thing. Good thing, hey, we don't have as many parts to troubleshoot. Bad thing, we've got it where it's not going to allow, we're not going to get all those service calls. But the good thing is we've got it where there's too many service calls already. There still are, even with all this new technology, there's still too many service calls. So if we can cut back on it while houses continue to be built, people can continue to be born, and the population continues to rise, we're going to have more HVAC units, more heating and air conditioning systems. So they're going to need to have more automation. They're going to need to be more reliable. As long as people maintain these systems, that will help. That will allow for that reliability to be there. So the big thing is, these older style units and stuff like that with these, liquid filled remote bulbs and old mechanical switches and everything, they're still used. They're still out there. So it's not, and it's it's not that you're not going to see them. It's just that it can be intimidating sometimes because you'll walk into a place and you'll never have seen equipment like that before. And what you have to do, what I encourage you to do, is take a step back, remember what we've gone over, think back on what you've seen in your books and in videos and everything, and try to just figure it out. How would this system work? You know, if I've got a pilot and it's a standing flame, there's got to be some way that gas is getting to it, that ignition takes place, that it continues to feed gas to itself. And this is what all these different systems are going to be doing and what they're going to allow to take place. This is how a pilot is going to operate, is by having these different, you know, flame sensing safety devices. All right. So safety devices at the standing pilot. Again, talking about standing pilots still. These are safety devices you're going to see in other styles of gas furnaces as well. I've seen thermocouples in direct spark ignition systems. I've seen liquid-filled bulbs in hot surface ignition systems. It just depends. For the standing pilot, this is where we're first starting to look and learn about thermocouples and thermopiles. What I want you guys to understand is that thermocouples, all right, and thermopiles, very much the same thing. All right, a thermopile, look at the bottom, bunch of thermocouples wired in series, right? They can actually generate voltage with that, basically, is the cool thing about a thermopile. What a thermocouple does is it sits directly in the flame, all right? It's going right there in front of that burner, right in the flame. Now, y'all all know that there is a byproduct always with electricity. That byproduct is heat, all right? The same thing is true for heat. A byproduct of heat is always electricity. Take your hands, rub them together, see if you get some heat, all right? You're also going to be getting static electricity built up. So you've created electricity and you've created heat. Now, for a flame in a gas furnace, it's going to be burning, and we need to convert that flame into an electric signal in order to get our system to know that it is burning properly. This is the whole point of this, to make sure that we are burning a flame properly. So for a standing pilot, this thermocouple sits in front of that flame all the time, because when is that standing pilot burning? It's a standing pilot, right? It's going to be burning non-stop. It's going to be operating. All right. As long as that system is powered on, if it's in standby mode, you're going to have a standing pilot. You know, the only time the pilot goes out is if it blows out, or you know, something like that happens. Now, with the thermocouple, it's going to be sitting right in the front of that flame. The problem with that is, over time, there's a byproduct we're always going to have with combustion, because we can't have perfect combustion. We get imperfect combustion. A byproduct is going to be soot. Now, soot acts as an insulator, all right? And it literally insulates the thermocouple and makes it so that it requires more and more heat to produce the same amount of electricity. So that's the whole thing. The thermocouple is going to take that heat energy, that flame, it's going to convert it to an electric energy, and then it's going to send that signal to your gas valve to make sure that that flame, that gas keeps flowing until, you know, it stops sensing it. And when will it stop sensing it? When the flame either goes out, or when the thermocouple starts to malfunction. And the most common way that a thermocouple malfunctions is with soot buildup over the thermocouple. this thermocouple buildup with the soot and everything like that, super easy to take care of. All right. Everyone here, I hope listening, has at one point in their life scrubbed some dishes and they come across a really nasty grease spot or something that was just cooked on, burnt into it. You probably use something like a Brillo pad or a scrubby side of a sponge to clean that off. It's the same exact thing we're going to use to clean our thermocouples, to scrub off that soot. And that's all you got to do. You just scrub it off a little bit, and you're going to see it's amazing how little it takes to clean off a thermocouple and make a huge difference. I'll let y'all know I had it one time. Went to a guy's house. Dude was a real piece of work because he called up saying it was an emergency heating call. I drove about 2.5 hours to go fix his emergency heating call in the middle of the night in January. Get to the house. The man had 2 gas furnaces and only one wasn't working. Problem? His thermocouple. His thermocouple was not operating and was not picking up a signal from the flame. Reason? Too much soot on it. Well, I charged him $500, to go clean all that soot and everything off that. Did it take me that long? No. Was that the thing I'm supposed to do? Yeah. Because he said it was an emergency call, and I told him how long I was going to be driving, and I have to be compensated for that drive time, for my parts, for my labor. And when it's 3 a.m. in the morning, I'm charging double on parts, labor, and drive time. So yeah, it ends up being $500. Sorry, bud. He could have waited. He had a second furnace. He also had like 3 fireplaces on the first floor, which was where the furnace wasn't working. He had like 3 fireplaces lit and full of wood. So the house was not cold at all. And his bedroom was upstairs, but he was up at 3 in the morning, I guess, and downstairs and wanted to be warm. So I don't know. But just letting you guys know, people don't know what it is. It's a simple, easy, quick fix. And if it's late at night, if it's an overnight call, if it's double check with your company. If you're running your own company, make sure you've got plans like that and set in stone, because there are going to be people that call you out and it's not an emergency and they'll say it is. And they'll be willing to pay. That's the thing. This guy had no problem paying that $500 because he was like, no, I understand. Like, it's the middle of the night. You drove all this way. It wasn't like, if I tried to do that in the middle of the day to a customer, they would be flipping. You only were here for 15 minutes and that's all that repair took and you're charging me $500? Yep. Like, yeah, no, that's not going to work in the daytime. Middle of the night, yeah, it works because people just need their heat working. But yeah, thermocouples, thermopiles, you'll see them used all over the place. Thermopiles, usually I see those on boilers in my experience that I've had. But again, can be used on any type of system. So a bimetallic safety device. What we're talking about here is a bimetal strip, all right? What the 2 metals in bimetal are, which at least I hope to God you do. Steel and brass, typically, all right? As that bimetal is heated, it's going to warp that metal, all right? This has it so when the pilot flame is lit, you're going to have a bimetal strip complete a circuit. It's going to close a circuit and tell the system, yes, now that I've completed power, I'm going to allow for power to pass, or now that I've completed a flame, I'm going to allow for power to pass through this bimetal safety device and keep this gas valve open for the pilot so that it continues to have a flame. This is a really nice device because it doesn't have to be directly in the flame. It doesn't have to be right in the middle of it. It can be just a quick little disc or a little bimetal strip, basically. And those don't have to be right in the middle of the flame. So building up soot on them really doesn't become as much of a factor as it does for our other ones. So this has got that as a major advantage for it. But basically, as long as that's got heat going, there will be gas flowing. That's the whole thing. As long as there's heat, gas will continue to flow to the pilot. When there's a call for heat, or let's say either a call for heat from the thermostat for a furnace, a call for heat from a water tank for saying, hey, I need the water to be a higher temperature, or a call for heat from an oven, let's say, preheat to 350 or something like that. That's when the pilot is going to ignite the rest of our gas. Rest of the time, the pilot just sits there waiting. Now, the liquid-filled remote bulb, this is a really interesting one. And it's probably the oldest style of this because it's the most basic, all right? Here's the idea. You put liquid and you have a little cylinder of it, and then you have a thin line, all right? Thin line carrying that liquid up to a diaphragm, all right? If that liquid is heated, it will expand. It will push on the diaphragm. It will allow for gas to flow through to our pilot, and then it will continue that process. So this basically, you have to press a button down, have a lighter in front of this liquid remote bulb, and then ignite the pilot and allow for that bulb to take over from that point. You can let your thumb off the trigger basically on that pilot trigger, and the remote bulb now will actually keep that gas line to your pilot open because it's sensing heat. The liquid inside that bulb is expanding and moving our components inside of the gas valve. Now, as these components are moving in the gas valve, this is what's allowing for gas to flow into our pilot, and it will allow for gas to flow to the rest of our burners. All right. The remote bulb only affects the gas flowing to the pilot, however. Problem with this is when the liquid cools, all right, for whatever reason. Let's say we've got it where the mechanical room, where you've got your water heater and your furnace and everything like that, is in a very poorly insulated mud room near the exterior of the house. This is a common spot, You're going to see water heaters and furnaces in garages too. If you work on first story stuff, a lot of stuff here in Virginia, they'll do that. They don't put in a crawl space. It's on the first story, and it's probably in the garage. So we've got it where the garage and those mud rooms and stuff like that that are near the exterior of the house, especially a garage, has got it where the air in that room can be especially cold. You can have wind rush in when someone opens the garage or opens even the door, and that cold wind blows in. If it's a really windy day or something like that, it can blow out a pilot, or it can just reduce the temperature enough of the liquid. If it's really cold, it can reduce the temperature in the liquid bulb so that it shuts the pilot off. And you won't even notice until you go to get hot water, or you go to get, it's 2 hours later, and all of a sudden, man, the house is getting really cold. What's going on with the heat? You look at the thermostat. Oh, it's off by 5-10 degrees. That's when people start noticing. So having it where this system, is in a well insulated area, is in a well protected place, is tucked away where it's not going to get wind or anything like that near it. That's important, and that's part of when they engineer and design the systems, they will choose to do that. For the liquid-filled remote bulbs, the biggest thing with them is understanding that they will build up soot on them just like a thermocouple. All right. And if it's got liquid inside of it, that soot acts the same exact way it does with the electrode. It's going to be an insulator. For a thermocouple or electrode, sorry, I shouldn't call it electrode, technically a thermocouple. For a thermocouple, the soot buildup is going to stop the transfer of electricity. For the soot buildup on a liquid-filled remote bulb, it's going to stop the transfer of heat and allowing that liquid to expand and move that diaphragm. That's what can happen a lot of times. Now, these you really don't want to be cleaning off with a Brillo pad as much. You can still do that. That's still a way to operate it and then repair it. But your best bet is to just, either replace it or you can take, there's solution they have for cleaning off these bulbs and everything like that. You can buy that at most supply houses. But those are your three basic types you're going to be seeing as far as safety devices. So going back, again, thermocouples and thermopiles, bimetallic safety devices, and liquid-filled remote bulbs. All right. So ignition systems, like I said, what we talked about this whole time is a standing pilot. What is a standing pilot? How does it operate? What's the difference between that and, you know, some other type of pilot? A standing pilot is the one that's going to be going on all the time, but an intermittent pilot, this is a very, very cool thing. All right, so question number 4 for your attendance. What is an advantage of an intermittent pilot? Question number 4, what is an advantage of an intermittent pilot? What is an advantage of an intermittent pilot? All right. Well, I'll tell you what the big advantage of an intermittent pilot is. Saves gas. Here's the big thing. All right, we've got it where the only thing that it's going to be doing is only going to be coming on when there is a call for heat. It is intermittent. All right, that means that it's not going to be operating 24/7. Basically, how an intermittent pilot is going to operate is that the thermostat or the aquastat or whatever's saying, hey, I need to heat something up, sends a signal. It's going to send that signal to the pilot first, all right? So this is where we still have it. We've got an ignition source. We're going to have something basically cause a spark or create that flame. And then we have a small flame that we started. And then once that small flame's proven, all right, turn on the rest of the gas and ignite the main burner. That's the whole point of an intermittent pilot. So the only difference with the intermittent pilots as far as operation with natural gas or LP is in an LP system, it'll close all the way. If it doesn't sense a flame, if it doesn't light or ignite, and with natural gas, the pilot valve remains open. It's not 100% shut off. So you've got it where it's going to have a solenoid basically that will actually be that shut off for it, if anything. Nowadays, you're usually having it where it doesn't matter. They're putting a shut off in it in all the systems, gas or natural gas or LP. But older style systems, you will see where natural gas just will let gas keep leaking out, or we'll have a solenoid controlling it. So I mentioned a second ago, we've got a few different types of ignition systems. All right. So the whole point of a pilot back in the day was, hey, let's put a flame right next to our burners so that when we introduce gas, they will all turn on, all the burners will burn, and we'll have gas going, and we'll have some heat burning. With the intermittent pilot, it's more so trying to make it where we can have an easier ignition, all right? So these components I'm going to talk to you about right now, the direct spark igniter or direct spark ignition and the hot surface igniter / ignition, those two are going to be used in a lot of different places. All right, number 5, sorry, next homework or next attendance question. This is number 5 for your attendance questions. It is, what is one major advantage of a DSI or direct spark ignition? I'm going to tell you right now, the big advantage to a direct spark ignition, it is windproof. All right. There's no pilot that's used or anything like that. We just have it where with a direct, this is talking about just straight up the direct spark and hot surface igniters. You can use direct spark igniters and hot surface igniters to light an intermittent pilot, but they can also be ignition systems on their own. So we talked about that whole thing where it's got to be up to like 1200 degrees in order for ignition to take place. Direct spark igniter is the most common for stovetops especially, If you've ever had a gas cooktop, or you've ever seen someone use a gas cooktop, or watched a cooking show where they're using one, and they turn the handle, and the first thing you don't see a flame, you don't see a red electric coil heat up right away. What you hear is a click, and then you see a flame. That clicking is direct spark ignition. What's happening is there's two pieces of metal basically, and they've got it where a small electric, or a large chunk of electricity basically is getting sent up to one leg of it, and there's a gap, and that gap is going to allow for that electricity to jump. Like if you've ever had a bad case of static electricity, you touched a doorknob or touched something metal, and you could actually see an arc go across from your finger to the metal. That's what this igniter is going to do. The direct spark igniter is going to allow for these two pieces of metal to create that spark over and over again. And when it creates the spark, it's going to be at a really, really high temperature. Because remember, a byproduct of electricity, which is all that spark is always going to be heat. So a small electric spark like that, just basically out there in the air, it's not controlled or anything like that, it's gonna have that 1200 degrees we need. So you'll see these used a lot of times. They are very, very common ignition systems because they last really long. The only problem with them is they sit inside of the flames. They're gonna build up soot on them. So just cleaning off the direct spark igniters is a good thing to do from time to time. But they really work very, very well. And the big advantage, like I said before, major advantage of direct spark ignition, it is windproof. If you have gas furnaces on packaged rooftop units and you've got 8 of them on the roof and each one's got 10 burners in it, that's 80 burners, all right? If I have to check and make sure that 80 burners are all igniting and burning and getting everything working correctly, that's a pain in the butt. And the last thing I want happening is ignition taking place, or a part saying, yeah, we can get ignition, but there's a strong gust up on the roof and now we can't get ignition anymore. So the direct spark igniter, this works very, very well, especially in windy locations. If you've ever seen online, there is a lighter that uses an electric spark to light cigarettes and all that kind of stuff. It's I can't remember the name of it, but it's like basically the electricity is in the shape of an X, and you just put the piece of paper, you put a cigarette or whatever in the middle of it, and then you can actually ignite that. As soon as it touches that electricity, it burns. So direct spark ignition works really, really well, and you don't have to worry about a pilot. You don't have to worry about wind. You just got gas burning, let's go. It's a very popular system for that reason. It's used all over the place. But I will say, it is not the most popular one when it comes to residential. Residentially, your most popular you're going to see is going to be the hot surface ignition or hot surface igniter. This igniter is going to be tested one way. And I'm going to explain that to you in a second, because question number 6 for tonight for your attendance: how do you test a hot surface igniter? You are going to test it with resistance. All right. You're going to check for resistance on a hot surface igniter. It's got 2 wires feeding into it, so you check from one to the other. Usually it comes in a plug, and you can just undo the plug, and then you can check those 2 leads on the other side of it. You'll check with ohms or resistance on your meter. You're looking for about 40 to 90 ohms typically, but anything below or above that is definitely abnormal. But always, check your manufacturer if they've got a different style or anything like that. It might be different readings you're looking for. You will see hot surface igniters used a lot. They glow bright orange basically right before they ignite the flame. They use silicon carbide. They've got a ceramic insulation that puts them right in front of the flame. They take in voltage. They hold on to an incredible amount of voltage and then send it back to neutral. And that holding on to it, that high resistance, allows for that to heat up and get to a high temperature enough so that we have ignition take place. We can have that 1200 degree ignition without having to have a pilot flame or anything like that. These are really common to go bad. Hot surface igniters, I would say, is probably one of the number one things I tested residentially and replaced on a regular basis when it came to furnace repairs and furnace maintenance. It's a common thing, you know. They're cheap. They cost maybe $15. Some of them, that's all it is. So you charge a customer like 45 if you're going crazy, but let's be honest, just charge them $30 and, you know, $20 for labor, $50 thing, and it takes you 10 minutes. So that's $50 on top of your dispatch fee. Don't forget that. But you know, that's the advantage of this hot surface igniter is you can have it where it just builds up resistance, ignites the flame, nice and safe. You don't have to worry, and you don't get that noisy sparking sound from a direct spark igniter. And if you've got a furnace that's in a place near, you know, a living room or kitchen or anything like that, it's a jarring sound when you constantly hear that clicking going on and off. If it's in a basement, who gives a crap? You know, it doesn't matter. But when it's in a common location, that's when it gets really annoying, and people will like opt for a hot surface igniter if they can. So they're really, really common. They're easy. I always kept a bunch of HSIs on my truck. It was the most common repair. Like I said, in wintertime, that was my number one. Summertime, capacitors. Those two got me through a lot. Not the only thing I had to repair, not the only thing I replaced, but definitely one of the most common parts to wear out. Again, hot surface igniters, they're sitting inside of the flame after they make that ignition. They're taking in incredible amounts of voltage and holding on to them. They wear down because of this, but they're very, very precise and they're cheap, so replace them often. The last thing you want to do is, you know, ignore a bad hot surface igniter and not let a customer know because you're concerned about the cost of it to the customer. Never be concerned with that. Let them be concerned with the cost of it. You just let them know what's going on with the system. So flame rectification, this is a newer style of flame, flame systems as far as flame proving devices and everything like that. This is where it's going to take it, and it's not just going to send a signal of voltage or anything like that, like you had with a thermopile, where it's literally selling or a thermocouple where it's sending millivoltage. This is going to send a different signal. This is going to basically, because of how the flame burns and how the flame sensor works. That's what it's called for a flame rectification device. It's a flame sensor. So these are used in conjunction or with the HSIs. They're used with direct spark ignition. They're used with pilot systems, intermittent pilot systems. This is just the newest way that we have to prove a flame is currently working and operating as it should be. So the flame is going to be the switch, and it's going to basically it's going to be burning. It's going to take that electrical energy from the fire. It's going to rectify it and convert it from AC to DC, and then basically tell the furnace, yeah, keep the gas valve open because here's this electric signal, and you know, keep it open. Now, it'll either be directly wired into the gas valve to do that, or it'll be wired into a board that will make the decision and controls based on how much voltage it's getting from that flame rectification device or that flame sensor. Again, there's a video I sent out earlier to y'all as part of today's lessons and everything like that, and it's got a really good explanation of flame rectification. Then he walks through, you know, how to measure it and all that kind of stuff. So, troubleshooting flame rectification, again, flame electrodes, they're going to be sitting in a flame. So they're going to get dirty. They're going to be corroded. You're going to have it where they can build up soot on top of them. And these are the things you got to protect against and try to maintain. Basic things like poor wire connections, disconnected ground will completely stop a flame rectification device from working. So just inspect your ground wires is always a good rule of thumb with them. I've had it before where that's literally all it's been, was not a damaged one, but a loose ground wire caused the whole system to fail. So these are the things you're going to be looking at, and you're going to be checking to make sure we're working on the system. Maintenance, you can replace them about the wires. It's saying every 3 to 5 years. If it's really an issue, if it's got it where that's a common problem with the system, I'd say yes. But typically, if you're replacing wiring, it's not like it comes in a bundle. You're having to cut, strip, and crimp on connections for everything. So it's not a quick and easy repair, but it is a good thing to maintain. Is to replace wiring once in a while, especially if it looks worn. The main thing I would do as far as wiring is concerned is I would test with resistance. If you test with resistance for your wiring, you're going to be able to tell whether or not it's working well, right? Good wire should have close to zero resistance. Bad wire will have higher and higher levels of resistance. We should have very, very low level of ohms. Again, it's saying keep your wire short. That is definitely a main thing you want to do because we're dealing with DC voltage. It's going to need large gauged wire, and it's going to need it where it's going to be traveling a short distance. You do not want to run this longer than what the manufacturer already has it set at, because this will be wired from the manufacturer. It's not like you're going to have to keep, you're going to have to figure out how to wire a flame rectifier in. And if not, you can always look at a wiring diagram. It'll show you exactly how everything's wired in. So electrodes, yes, again, need replacing. Thermocouples, there are some times where you cannot clean them off enough, and it will just need to be, got to get you a new one. But again, these parts and components are cheap in comparison to HVAC, in comparison to air conditioning, refrigerant, and coils, and all that kind of stuff that's real expensive. Gas furnaces are very, very cheap to maintain and to operate. And the last thing it's saying there, burner gas pressure must be correct. Again, we'll talk about that more, especially when we get into measuring and testing gas pressures in a system. There's two different things with the rectifier that can be a common issue: silicone contamination and aluminum oxides buildup on it. So these are both able to be scrubbed away, basically. The contamination, you basically got to make sure that you're not getting too much buildup on it, and you want to make sure that you don't have cracked ceramic as far as your insulation or anything like that. You just want to make sure that everything is operating as it should, and nothing's popping out of the ordinary. So cleaning these off, that's going to be your easiest way to repair them and to make sure that the system operates efficiently and well. All right, so in summary, 3 types of safety devices are standing pilot. 3 types of safety devices for your standing pilot are your thermocouples, your bimetallic devices, your liquid-filled remote bulbs. You got 3 different types of ignition systems. You've got your intermittent pilot, that IP, your DSI, direct spark ignition, or your HSI, hot surface ignition. And your flame rectification systems, you use a pilot flame to conduct electricity. That electricity is used by the board or by the gas valve to allow gas to continue to flow through the system. These flame rectification devices are not used to prove that we've had a pilot lit. They're used to prove we have burners lit. That's what we're going to be looking for, especially with direct spark ignition and HSI. Your flame proving devices will not be by the ignition sources. They will be on the other side sometimes. Some direct spark igniters will have it tied in, but most will have its own sensor and everything.